All right, in this video, we are going to learn rules for transformations and how we can describe them using coordinates. So we're going to start off with a little graph like we did last time. And we're going to make a very simple triangle. We're going to put one corner at 2, 1, the next one at 2, 4, and then the last one at 3, 1. Let's label those A, C, and B. And don't forget to label the X and Y axis. All right, so the first one we're going to do is a translation. So translations are the easiest. These ones you're just going to add or subtract the number of coordinates that you want it to move to the right, left, or up, down to the X or Y axis, depending on which way you want it to go. So we're going to say add or subtract from the coordinates. So for example, if I wanted to move my triangle 3 units to the right and 2 units down to the right, that's the X direction. So I would do X plus 3, and down, that would be like a Y direction. So I would do Y minus 2. Okay, so what this means is that we can figure out exactly where the image is going to go without having to like eyeball it and without necessarily having to see it on the graph. So I'm going to make a little table to show what that looks like. So we're going to set this up where we have the original, and a lot of times we call the copy the image. So I'm going to use that vocabulary, the image. Okay, so first we need our original coordinates. So we said that A was at 2, 1, B is at 3, 1, and C is at 2, 4. Okay, now my image, I said that I'm going to move to the right 3. So I'm going to take each X coordinate and I'm going to add 3 to it, and that's going to move it 3 units to the right. So 2, 1 is going to become 5 because 2 plus 3 is 5. And then the Y coordinate, I have to subtract 2. So instead of 1, it's going to be at negative 1. I'm going to do the same thing for B. 3 plus 3 is 6. 1 minus 2 is negative 1. Right? I'm just applying this rule to each of the points one at a time. And then finally, C, 2 plus 3 is 5. 4 minus 2 is 2. I can check my work by graphing it to show that this does actually work. So I'm going to go to 5, negative 1. 1, 2, 3, 4, 5, negative 1. 6, negative 1. And 5, 2. And when I connect that, sure enough, it looks like I took the same triangle and I just translated it over and down. I'll label my new points. This becomes A prime. Oops. That one's C prime. And this one is B prime. All right, so that's a translation. We can also do a reflection. So we're going to write a rule for a reflection just for whether you're reflecting over the x-axis or whether you're reflecting over the y-axis. We're not going to write rules for reflecting over any other random lines, but that means we need 2 different rules. So if we're going across the x-axis, if you picture it, you're taking something and you're flipping it down. So the x-coordinate should stay the same and the y-coordinate should flip. So across the x-axis means that you take your coordinates and the x stays the same and the y becomes its opposite. So we say negative y. If it's a negative number, it'll become positive. If it's a positive number, it'll become negative. And then flipping across the y-axis is similar, except it's going to do the opposite. So across the y-axis, right, we can picture that again. The y-coordinate stays the same and the x-coordinate becomes the negative. All right, so once again, let's do this with our friendly little triangle here. Okay, so I set up, we have those same 3 original coordinates. I'm doing this all from the original. And now I'm going to find the image. And let's go ahead and do this across the y-axis. So that means that my x-coordinates are going to become their opposite. If they were negative, they would become positive. In this case, they're all positive, so they're going to flip to being the negative. So -2, 1, -3, 1, and -2, 4. So that we can graph them and visually check that this does look like it is a reflection across the y-axis. So -2, 1, -3, 1, and -2, 4. And yes, this does look like if I were trying to reflect that original triangle right there, it's reflecting it over there into that spot. All right. Finally, let's talk about rotations. So rotations have a center of rotation. We're just going to use the origin for those, although in later geometry classes, you will use different coordinates too. And we're going to write the rules as though we're always going counterclockwise. Okay, so this one, we're just gonna define 3 different ways you could do it. So if you were doing 90 degrees, that would be taking the original coordinate and you actually end up swapping the x and the y and making the y be negative. So that becomes -y x. You'll have to try it on paper to like make sense of how this works. And then if I had 180 degrees, that one does not swap the x and the y. That one keeps them both in their right spots, but it makes them both the opposite. So xy becomes -x, -y. And then a 270 degree, which of course that's the same as like a 90-degree clockwise rotation. That gives you y -x. So notice how, and so a 270-degree rotation, that's like almost all the way back where it started, or you could think about that as being a 90-degree clockwise rotation. That would be one where you would switch the coordinates, the x and the y, and then make the x negative. So let's see how that one works. All right, so we're going to take our original triangle and we are going to do a 270-degree rotation. So instead of a 2, 1, it's going to flip. So it's going to be a 1, 2, but the x is going to become negative. So this will become 1, -2. For B, once again, they flip. So 1 goes in the front, 3 becomes the new y coordinate, and it becomes the opposite. And for C, they swap. So 4 first, and the 2 goes second, and that becomes negative. So let's see what that looks like on the graph. So we have 1, -2, 1, -3, and 4, -2. And if we picture that, that does look like we rotated it 90 degrees clockwise or 270 degrees counterclockwise. So that one worked too. All right, so practice problem. What are the new coordinates of the point -3, 5 after a 90-degree counterclockwise rotation around the origin? Good luck.